Good afternoon to panelists and judges. Welcome to my poster presentation. Our topic today is efficient design of hydro turbine management unit for standalone Pico hydro in rural area. Abstract. Recent research indicate that intelligent control might be a viable method of achieving optimal comfort levels at better efficiency. Thus, an integrated efficient turbine management unit were proposed in this research. This turbine management unit will include the intelligent control so that to show a better performance for the outputs. Problem statements. Previously, in order to satisfy community in rural area of Borneo with electrification, stand-alone Pico hydropower always be the most suitable renewable energy source and the best choice. However, poor regulation and low maintenance causing unstable power supply after the system installation. Thus, frequency control become one of the most important factors in power system, since it is an indicator for energy balance and power quality in the system. As we know, flow control valve or electronic load controller is a very common control strategy. However, neither flow control nor electronic load controller both will have the drawbacks in terms of frequency response and also harmonic distortion due to regular switching on and off of the dump load and energy wasted in dump load issues. While stand-alone will causing a poor output in terms of the frequency response time. And so, integrated unit were proposed in this research to prevent all these poor regulations. The method that we are using in this research is it will be conducted in software MATLAB simulation for the first. After that, hardware installation is done in Sunvision Engineering Sdn Bhd, and the pilot test will be implementation in Sarawak rural areas. Now, let's proceed with the how do hydro turbine management unit works. From diagram 1.0 Pico hydropower system, we can see that there is the efficient hydro turbine management unit with integration control. For the left-hand side in the diagram, intelligent valve control with fuzzy logic and PID controller will function to control the valve, while electronic load controller with PI control will control the generator output. Due to seasonal weather in Malaysia, uncertainty of the flow rate causing unbalanced situation exists between power generation and load demand. Thus, turbine governor with intelligent valve control using fuzzy logic controller will control the on-the gate opening. This is to produce just the necessary power according to the connected load. But on the same time, electronic load controller will also govern the frequency by regulating the electrical load connected to the generator. Two controllers will work together at the same time so that to overcome the stability of the power system. Our innovation idea also will include the battery energy storage system, which is store energy from the renewable energy source and supply power up to at least 5 days in case of the power failure and insufficient of electricity production in rural areas. Through these renovation ideas, the expected outcome is this hydro turbine management unit will show an efficient system and better performance of frequency response in terms of reducing the overshoot time, labeled as A in the graph 1.0, and transient response, labeled as B, and steady state error, labeled as C, in the graph. This will ensure by reducing these parameters by at least 3% and also lower down around 2% of the harmonic distortion in the output to ensure the stability of the system. Research significance. This research project will contribute a simple, convenient, and efficient hydro turbine management unit, which is highly regulated and provide power stability to remote communities. Integration of both controllers will show an efficient and better performance of the frequency response. Result of this work will provide an example of how green energy solution for rural application could be highly contextualized to ensure maximum impact and long-term sustainability. And also, battery energy storage system will maximize the energy utilization during high electricity demand and breakout period, which is considered the first implementation in Borneo, Malaysia. It will reduce the possibility of electricity downtime and disruption, especially in rural areas, which we know that rural areas is always from the town city areas. With this hydro turbine management unit works, it will prevent and lower down the maintenance cost. As a conclusion, the proposed unit can be used with different power output and different head by varying the input of the actuator valve. Good transient and steady state response for different operating points of the process can be achieved by implementation of this unit. By this, the proposed units can be recommended as a promising alternative controller to control any other micro hydropower plant in rural areas where no grid will be installed in the future, especially in remote communities such as Sabah and Sarawak. This research currently is in process and work together with Swinburne University of Technology Sarawak and collaborate with Sun Vision Engineering Center Berhad so that to came out hardware unit and implementation on Sarawak rural areas. Besides that, this research idea is on progress apply for the fundamental research grant. That is my presentation for today. Thank you very much.